Morning, all of you. Hope all are doing well. So, in the previous class, we completed the first chapter successfully, that is science. The second chapter is integers. And we know natural numbers. Natural numbers are counting numbers. We denote natural numbers by letter n. Those are 1, 2, 3, 4, and so on infinite. If we included 0 to natural numbers, then so form set is called whole number set. We denote whole numbers by letter W. And now integers. We denote integers by letter I. If we include negative numbers to whole number set, then that set is called integer set. That means whole numbers will be as it is 0, 1, 2, 3, and so on. And along with this, negative numbers also included in this set, and so on infinitely. So you have like positive numbers infinitely, negative numbers also infinitely will be in this set. It means all positive numbers, all negative numbers along with 0 is said to be as integer set. So that integer set is denoted by letter I. Now, how to represent this integer set on number line means draw a number line and mark somewhere as 0 and right side to 0 with equal distance mark points. That means 1 centimeter distance. Here 1, next number 2, next number 3, next number 4, and so on. And left to this 0 with equal distance again mark negative numbers. That means -1, -2, -3, and so on. And this is the process of marking integers on number line. Once again, integers. Before integers, natural numbers. Natural numbers means all counting numbers are natural numbers. We denote natural numbers by letter n. If we included 0 to the natural number, then obtained set is called whole number set. Then the elements in the whole numbers are 0, 1, 2, 3, 4, and so on. If we included negative numbers also to the whole number set, that means all negative numbers, all positive numbers along with 0. So form set is called integer set. We denote integers by letter capital I. And this is the process of representing integers on number line. And the next. The next one is successor and predecessor. Successor and predecessor of an integer. Successor means if we added 1 to the given integer, so formed integer is called successor. That means take 2, add 1 to 2, what will obtain 3. So 3 is called successor of 2. Success, when you will success in 6th class, you will be promoted to next 7th class. That means success, you will promote it, you will go to next step. Next, predecessor. Predecessor means predecessor. Previous means previous. So that means clearly previous number. To get previous number, what we have to do? We have to subtract 1. To get successor, we have to add 1. To get predecessor, we have to subtract 1. So predecessor of 2 is 2 minus 1, that is 1. And what about negative numbers? Whatsoever, take -3. Successor of -3. Successor means we have to add 1. Predecessor means we have to subtract 1. So successor of -3 means +1. -3 plus 1 gives us -2. So -2 is the successor of -3. And the next predecessor of -3. Predecessor means we have to subtract 1. So -3 minus 1 gives us -4. So like that, successor, we want to find a given integer means we have to add 1 to the given integer. Predecessor we have to find means we have to subtract 1 from the given integer. Next, absolute value. Next, order of integer. What is the order? So means if we observe on number line, the numbers which are right side to 0, that means positive numbers, The numbers which are left side of 0 are negative numbers. That means right side, if we are moving step by step, each and every integer is greater than the previous one. Observe 2. Go to right of 2. 3 is the greater than 2. Next, go to right of 3. 4 is greater than 3. That means every right side integer is greater than the left side integer. Here also -2, -1. Compare these two. Right side if you move means -1 is the bigger than -2. And now coming to left side, right to left, 4. Come left side. What is left side of 4? 3. So 3 is the smaller one, and 3 left side to 3 is 2. 2 is the smaller than 3. Next same like that. -3 is smaller than -2. That means if we are moving right side, the bigger numbers will obtain. If we are moving left side, then smaller numbers will obtain. So clearly all positive numbers are greater than 0. All negative numbers are smaller than 0. So here -1000 and so on -1000. So minus, that is 1000, then also it is smaller than -1. Why? Because negative number it is. So all negative numbers are smaller than positive numbers. And moreover, what's the numbers will left side of the given integer is smaller than that number. So these things we have to remember. And next, absolute value of given integer. What is absolute value? Absolute value of an integer is a numerical value of that integer, irrespective of its sign. That means -5 is there, 5 is there. Two numbers, one is -5, one is 5. Absolute value of -5 is 5. Absolute value of 5 also 5. Whatsoever its sign is, whether it may be minus or whether it may be plus, absolute value means we have to take only its numerical value. Minus, take numerical value only. Here plus, take numerical value only. So that is numerical value of the given integer irrespective of its sign is called absolute value of that number. And generalized, if a is an integer, x is an integer, then if x is greater than 0, then modulus of x is equals to x. So this is absolute value representation symbol. We have to read this one as modulus. And modulus of x is equals to x. When x is less than 0, modulus of minus x is equals to minus of minus x. Simple generalization, simple, easily we can remember. X is greater 1, that means 5. Modulus of 5 is 5 only. Next, x is less than 0, that means minus 5. Minus x means minus 5. Then absolute value of this minus 5 is equals to minus of minus 5. That means minus of minus 5 is plus only. Whatsoever positive value only we have to take absolute values. So these things you have to remember. And next problems we will solve in exercise 2.1.